Today we're going to take a look at the answers to the HMH into Math on your own interactive assignment. A race official wants to place water bottles between the start and finish line so the race course is divided into 3 equal sections. What drawing shows the situation? What is the distance between each station? So we're going to look at which of these models over here looks like represents the distance between each station. So we know that we're going to start with 6 and 21 hundredths, but I'm going to need to cut that up into 3 equal groups. So what I'm looking for in my answer is which one shows 3 equal groups. Here I'm going to circle the group so that my eyes have an easier time. I'm noticing here that I do have 6 and 21 hundredths, but those are not 3 equal groups. In this situation, I have 2 and 7 hundredths, 2 and 7 hundredths, and 2 and 7 hundredths. Those are equal groups, so I'm just going to write that down before I move on to make sure I have eliminated all my other answers. This, and let's mark off that one because we know that's not true. In this situation, it looks like they just divided 2, 2, and then 2 and 21 hundredths. Those are not all equal groups, so that one's out too. Finally, we have this situation where it is 2 and 11 hundredths, 2 and 1/10, and 2. Nope. So our correct answer is 2 and 7 hundredths. So the first step here was to represent 6 and 21 hundredths with the 6 squares, which we have here, 2 sticks, and the 1 little dot. That's a quick sketch. Then what we needed to do here was we needed to divide these 6 squares into equal groups of 2 because we're making 3 equal groups of 2. Now, when I'm done with my squares, I always like to just cross them off so I know what I am done dividing. Great. Then I need to take these because I can't put 2 sticks into 3 groups, and I have to make these into 21 little dots, which 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and this little guy is 21. Okay, you get the idea. And then I'm going to take these 21 dots, and in each group, I'm going to divide them into, there's 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So there we have it, 2 and 7 hundredths. Joaquin cuts a board 4 and 68 hundredths feet long into 6 equal pieces. How long is each piece? Normally when I do this, I would make a model where I would say, okay, I know that the total length is going to be 4 and 68 hundredths, and I know that there are going to be 6 equal pieces, so that tells me I'm going to need to divide. But now I'm dividing with decimals, so I have to think about how long each one of these is. If I'm splitting this decimal, it gets a little tricky. So sometimes it's nice to make a very quick sketch, and I can show you how to do that right now. If you look closely, you can see I've even hidden inside this board these little squares to kind of prompt you. So let's take a look. I'm going to go ahead and I'm going to quick sketch 1, 2, 3, 4 whole feet, and then 6 tenths, and then 8 hundredths. Okay, now that we've got that, I need to share them into 6 equal groups. I cannot easily share these 4 whole pieces. I'm not even going to think about the other pieces yet. What I'm going to have to do is I'm going to have to break each one down into 10 sticks. That's a little challenging. So what I'm going to do is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then these longs, which are 6, are going to come down anyway. 1, 2, 3, 4, 5, 6. And this cute little group of 8 dots is still going to be there. 1, 2, 3, 4, 5, 6, 7, 8. Now I can start making my groups. I need 6 groups. So I know this is 10, 20, 30, 40, 6, and 800ths. Hey, look at that. I wonder if I take this, I'm noticing something. I'm noticing when I break it into tenths, I get 46 tenths and 8 hundredths. And I'm thinking if I broke it down even further, I would get 468 little tiny hundredths. I'm not sure if we'll need to do that yet, but that does play into how we're going to divide. So back to what I was saying with the number dividing into 6. I really want to think about how I can best share these 46 pieces. I want to think about that before I start. So I've got 46 tenths, and I'm going to think of a number that's kind of close to 46 that I know can be divisible by 6. So I'm going to go with 42. I know that 42 divided by 6 equals 7. So I know I can put at least 7 in each group. So let me make a little group of 7. 1, 2, 4, 5, 6, 7. And then I'll just do a group here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's getting a little interesting here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I wonder if I'm going to have any left over. I don't know. I think I am, because 46 is not 42. 1, 2, 3, 4, 5, 6, 7. So there's my 6 groups of 7, but I still have this left over. I still have 4 tenths and 8 hundredths. I can't share these 4 tenths anymore into 6 groups. So what I'm going to have to do is I'm going to have to say, okay, I'm going to change you into 48 little tiny squares. And I know that I can take 48 and I can divide it by 6 and I can get 8 little dots in each group. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then they're all gone. So in each group, we end up having here 7 tenths and 8 hundredths. So each piece of the board is 78 hundredths of a foot long. That one was a little tricky. Okay, for this, I think what we're going to do is I'm going to show you the long division way to do it, the box method, just for time's sake. So we had that same idea where we're going to see if we can share these. And if I were going to do this, I would make boxes. Right? I would make 7 boxes. It'd be very exciting. 1, 2, 3, 4, 5, 6, 7, 8. And then I could put them into 6 groups. I'd have 1, 2, 3, 4, 5, 6. Okay. So I know for a fact that would give me 1 whole. And I know that 1 whole, 6 groups, would give me, I'd have 1 whole left over, and then I would have another 8/10 left over, which is what we see here outlined in red. Okay, great. Now, I can't put this group into my groups of 6 because clearly I can't do it the way it is. It has to be split up. So what I can do is I can take this whole and I can trade it for 10 ones, 10 tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now, if you look, I have 18 tenths. Do you see how that kind of looks like 18 tenths? If I moved this over, 1 8/10 is the same as 18 tenths. I know I can share 18 tenths 6 ways. So I would do 1/10, 2/10, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And I would get 3 in each group. So I know I would have 1 whole, which I have here in the box, and I would have 3/10. And I know that 3 times 6 is 18, and I wouldn't have anything left over. Here's another one. For this one, I don't think we need to do a model. I think we can just use our basic facts. I'm going to write it a little bit bigger so that we can really think about how to move that decimal point. I'm going to estimate first. I am taking a group of 4 and 5/10, which is smaller than 5, and I'm putting it into 5 equal groups. Do you think my answer will be more than 1, less than 1, or the same? My answer is going to be less than 1 because I'm starting with something that's smaller than 5. It'd be like saying, here's $4.50, split it with your 5 friends. Each person is not going to get $1. But what I can do is I can think about ignoring this decimal for just right now, and I'm going to notice my basic fact. And I do see a basic fact here. I see 45. I'm going to trace over it in red just so you see. 45 divided by 5. And I know 45 divided by 5 is 9. My common sense is going to tell me that 4 and 5/10 divided into 5 groups is not going to give me 9 in each group. So I know it's going to be less than 1. So my common sense is going to tell me that it's going to be 9/10. Here's how I'm going to check it. I know that in order to divide by 5, I probably had to take this 45 and I had to change it, and I had to make it into 45/10. So I've got 1 decimal point here. So in my 9, I'm going to have 1 decimal point here because we're talking about it in terms of tenths. Here's another one. For this one, let's just do the straight box method, just because I think we're ready for that. So it's a partial products. We know how to do this. We're looking at 7s. I have my 9 and 45/100. With this situation, we are going to really try to think about numbers that work well with 7 and our 7s. And then over here, I'm going to have you add them up. Okay, so 7 into 9. I think I know I can make at least one whole group of 7 with 9. So I've got 1 here. Okay? 1 times 7 is 7. When I do that, I have 2 left over. Keep that decimal point the same because I'm subtracting. Great. Now, let me put my decimals right there. Okay, now I cannot do anything here with 7 into 2 groups of 45/100. So I'm going to try to think about this as if there's like I'm making it into 24/10. Okay, 24/10. So I know my next answer is probably going to be in tenths. I'm going to put that right up there. So how many groups of 7 can I make out of 24/10? Those are like if we had the little sticks. I had 24 of them. That's a lot to draw. I think I could make 3. I could put 3 in each group. And if I put 3/10 in each group, it would be 21/10. Okay? And what I would have left over is 3/10. I'd have 3 little sticks left over when I was done. And I'd have 5/100. 5. Now, I can't do anything with these sticks and hundredths. That doesn't work. I'm going to have to break them up. Okay, so now I've got this, and now I can think about it like this now because I'm dealing with hundredths. So I know my answer is going to be how many hundredths are going to be in each group. Well, I know that I could, if I had 35 hundredths and I was sharing it 7 ways, each group would have about 5 hundredths in it. And 5 hundredths times 7 is 35 hundredths. So my answer would be, if I add up all my partial products, 1 and 35 hundredths. Okay. Here's another one. Which division equation is shown with the blocks? Well, it looks like I am sharing something into 3 equal groups, so I can go ahead and put that there. And it looks like each group is going to contain 55/10 and 4 hundredths. 4. So something divided by 3 equals 54 hundredths. Well, I could also just count them up. I could also use inverse operations. But I can tell if I added these all up and I put them into a group, this would be 1 whole, and then I would have these, oops, this screen, I would have these would be another, say 1 62 hundredths. So it's 1 62 hundredths divided by 3 equals 54 hundredths. Okay, which, yay, we got that right. Which real-world problem can be solved using the equation from part A? So we want to talk about something where we are sharing a total of 1 and 62 hundredths into 3 groups. And when we do that, we find out how much per group. So let's go through our situations. Number 1, Mr. Henry has 3 boxes of crayons that each weigh 1 and 62 hundredths. How much is the total weight? It doesn't look to me like we are sharing. It looks like we are multiplying. So nope, sorry, Mr. Henry. Mr. Henry buys 3 boxes of crayons that weigh a total of 1 and 62 hundredths pounds. If each box is the same weight, how much does each box weigh? That might make sense because I have each same. How much does each weigh? And we're starting with a total and we're sharing it by 3. I think I'm going to maybe star that one to come back to. Mr. Henry has 3 pounds of flour in the bowl. He has too much, so he takes out 1 and 62 hundredths of a pound. How much is left? No way, Jose. That is subtraction. Nope. Mr. Henry has 1 and 62 hundredths pound of flour in a bowl. He adds 3 more pounds of flour into the bowl. How many pounds of flour does he have? He has a lot of flour there and he has way too much to make cookies and it's addition, so sorry, Mr. Henry, that is not it. We're going to go with this one. He's sharing it 3 ways and we've solved the mystery of Mr. Henry.